this is another very important example of the another kind. If a subspace W of three-dimensional vector space R consists of those vectors whose first component is 0, then we have to find the basis and dimension for W. Now it is given that first component is 0. That is, the elements present in W is of the type 0, y, z, such that yz belongs to the reals. If second component is 0, then the element becomes x, 0, z. And if the third component is 0, then the element becomes x, y, 0, such that x, y belongs to R, right? So this is how you have to take the elements for W. To get the basis for W, let's take one element from W, and that is 0, y, z, that is belonging to W. Then the 0, y, z can be written as the sum of 0, y, 0 plus 0, 0, z. That is further equal to y into 0, 1, 0 plus z into 0, 0, 1. So you have noticed that this element 0, y, z becomes a linear combinations of the vectors 0, 1, 0 and 0, 0, 1, right? But this 0, y, z is arbitrary element of W, right? So because 0, y, z is arbitrary, that means every element of W is a linear combinations of these two vectors. So therefore, every element of W is a linear combination of 0, 1, 0 and 0, 0, 1. Thus, W is generated by the vectors 0, 1, 0 and 0, 0, 1. Let's write these vectors in a matrix form. Fine. Alright. So because this matrix is already in a row echelon form, so from first row we are writing the basis as 0, 1, 0, and from the second row we get the vector 0, 0, 1. So these two vectors forms the basis for W. Because these are only two vectors, so the dimension of W is 2 here, right? Okay, these are the few exercises. Please try these. First one is, let W be the subspace of R3 of all vectors. Now vectors is given to be as of the kind A, B, 0, right? So you have to find the basis and dimension of W. So here W is A, B, 0 such that A, B belongs to the reals. Just write element of W to be the linear combinations of vectors and get those vectors to be as a basis for W, right? If those vectors generates this W. Second is, if a subspace W of R3 consists of those vectors whose second component is 0. So here W is, yes, second component 0 means x, 0, z. The second component is 0 such that x, z belongs to the reals, and B part third component is 0. So here W is for the B part, it is x, y, 0, right? Third component is 0 such that x, y belongs to R. And just proceed as in the previous example. And here the answers are already provided with these exercises. Please match your answers and check the basis, right? Okay, thank you. Stay blessed.